WBJEE 2021 crash course by Dream Academia. My name is Swastik Mukherjee, and today we are going to be solving some problems on kinematics. So let's begin. These are going to be basic problems involving some projectile motion, basic kinematic equations, and some conceptual problems. So let's begin without any further delay. A body moving in a curved path possesses a velocity of 3 meters per second towards north at an instant of its motion. After 10 seconds, the velocity of the body was found to be 4 meters per second due west. Calculate the average acceleration during the interval. Okay. So the problem is asking us to calculate average acceleration. What is average acceleration? It is final velocity minus initial velocity at the time. What is the final velocity? Final velocity is 4 meters per second due west. Now what is the initial velocity? It's 3 meters per second towards north. So the initial velocity minus of that will be 3 meters per second towards south. And the resultant of that will be 5. Because as you know, okay, let's draw this here. This is looking a little weird here. Let's draw this here. Okay. So as you know, a 3, 4, 5 Pythagoras triangle is very common and it appears a lot of times in many physics problems. You should have the angles of this by heart. Now many times we will get confused as to what is 37, which one is 53. So you should remember that by the tan theta. So now tan theta 1 is greater than tan theta 2 if theta 1 is greater than theta 2. And 3 by 4 is less than 4 by 3. So the angle opposite to 3 will be always lesser than the angle opposite to 4. Angle opposite to 3 is 37. Angle opposite to 4 is 53. You can remember this by this method. I used to do that. Okay, so what is the problem asking us? Average acceleration. So we got 5 meters per second. Now we have to divide it by time, which is 10 seconds equals 0.5 meters per second square. Now we have to also specify the direction. Now this is mod of A. It's not, the direction is not specified here. This is mod of A. 37 degrees south of west. Now what is this? This is west. This direction is west. And this is 37 degree south of west. So option A is correct. They will always confuse you with these types of options. So you should not be scared by them. You should just solve your problem, see the answer, and then move on. Okay, next problem. 3 grooves AB, AC, and AD are made in a circular disc lying in a vertical plane. 3 particles BC and D, constrained to move along path AB, AC, and AD respectively, are released from point A. Particle B reaches point B in time TB, particle C in time TC, and particle D in time TD. And which of the following is incorrect? Okay, so let's consider the diameter of the circle first. Let it be D. And let's say this distance AB. Now since this is the diameter, this is 90 degree. Also this is 90 degree if I draw a line here. So what is this? If this is D, this is D cos alpha by 2, and this is D cos alpha. Okay, so let's consider the particle that is moving to point C, the easiest. So let's use our standard kinematic equation for that, which is minus D. It starts from rest, so minus D is equal to minus of half G DC square, implies DC is equal to root over 2G 2D by G. Okay. So that's our TC. Now for the other two, Let's clear some concepts here. Concepts should be very clear while solving physics problems. So this particle is moving along this groove. What are the forces of this particle? There's G. Okay, so this angle is alpha by 2. There's G, which can be broken down into G cos alpha by 2 and G sin alpha by 2. And there is also a normal reaction acting on this particle. Okay, so what concept should be very clear here is that the motion of this particle is constrained along this direction, and there is no motion happening along this direction. No motion. So these forces are not playing part in the motion or the kinematic equation of this particle. They would have if there was friction, but there is no friction. In this problem, they have mentioned no friction, and thus we will ignore it because we are JEE aspirants. So the only force that is concerned with the velocity is G cos alpha by 2. So we can just write a kinematic equation like T, let's say B, equals to, wait, we'll solve from the beginning, minus D cos alpha by 2 is equal to minus of half G dB square. Sorry, so G cos alpha by 2 implies dB equals to this will get cut off is equal to root over 2D by G. The same rule applies for TD, which is the motion of the particle in this groove. The angle is just alpha, it's on the other side. The same logic applies. So minus d cos alpha equals to minus half g cos alpha d square implies dd equals to root over, this will get cut off, 2d by g, which means dB equal to dc equal to td. So we will mark this problem, this portion, right? No, you will not. This and this are correct because they're asking which of the following is incorrect. This mistake is done by so many JEE aspirants over the years that it's quite shameful. But I've also done this mistake many times. Thankfully not in the exam. You should always, people solve the problem and then they go back to the question and they just, in a hurry, they just mark it full of excitement because they've solved the problem. Because they should always remember what the question initially asked, and after solving they should keep their head cool and go back to the question, read what they're asking and safely take the answer and move on. A particle moves over the sides of an equilateral triangle of side L with constant speed v as shown in the figure. Okay, so these types of problems will have questions in the options, so you should always read these options very well. And mind you, all these questions I'm doing are multiple correct because those types of problems are the most challenging and you will face them in WBJEE and also JEE Advanced, not in JEE Mains, but they have changed the format now. It used to be that you didn't, but now you do. Okay, so the magnitude of average acceleration from A to C is V. Okay, they want the average acceleration and the average velocity from A to C. We'll calculate both. So for the average acceleration, what is average acceleration? It's V final velocity minus initial velocity by time. Now what is final velocity? It is from A to C, so final velocity is Vc, is this angle being 60 degree, and the initial velocity Vi, so you can see, okay, is 60 degree also, this angle. So what they want is V final minus V initial by T. This is the average acceleration. So mod of A average, this is mod, is equal to, now these horizontal components get cancelled right out when you subtract. So only the vertical components remain. So mod of average, A average is 2 of mod of VA equals mod of VC equals V, because it's moving with the constant velocity V, is 2V sine theta, which is 6 degree, by the time taken. It's moving with a constant speed V and it travels from A to C, which is a distance of 2L. So the time taken is 2L by V, which is equal to root 3 V square by 2L. So option D is correct. Now the magnitude of average velocity as it moves from A to C, let's calculate that as well. What is average velocity? This is the displacement by time, which is, well, the displacement is L because it moves from A to C, and the time, as you already know, is 2L by V. So this is V by 2. So option B is correct. Let's move on to the next one. A body falling freely from a given height h hits an inclined plane in its path at a height small h. As a result of this impact, the velocity of the body becomes horizontal. For what value of small h by capital H will the body take maximum time to reach the ground? Okay, normal kinematic problem. Let's solve it. Okay, so first of all, this is h minus h, and the body is at rest. So let's apply our standard kinematic equation first. Let's call the time it takes to reach this platform T1. Implies T1 equals to root over 2h minus h by g. Now for T2, the body has a completely horizontal velocity, it says, which means that the vertical velocity is again 0 starting from this point. So we can again apply our same kinematic equation for T2, which is minus small h to minus half g T2 square, implies T2 is equal to over 2h by g. Now what are they asking? They're asking what value of h, which is capital H, will the body take maximum time to reach the ground. So they are trying to maximize T1 plus T2. Let's do this here. So T1 plus T2 is equal to root over 2 into h minus h by g plus root over 2h by g. They're trying to maximize this, and what is our variable here? H is constant, capital H. Small h is variable. That is the position of this inclined surface. So we do a ddh of this is equal to root over 2 by g. You can take this constant out. Minus 1 by root over h minus h plus 1 by root over, means we have 2 here, 2 root h. Now this is equal to 0 because we're trying to maximize here. Implies root over h equals root over h minus h, implies h to h equals h, implies h by h is 1 by 2. So This answer is correct. Now, there is also another way to solve this problem, qualitatively solving this problem. Now, I would recommend not going this approach if you're not comfortable with the concepts, and if you don't feel you're comfortable, always the surefire analytical approach is the best, I would say. But there's also another qualitative way of solving this problem. So let me show that. I'll do it. So they're asking for what value will it take the maximum time, right? So what do you think will be the minimum time? Let's erase all this. What do you think will be the minimum time? What condition will cause it to have minimum time? So let's analyze this. This body is falling. It's hitting this inclined surface, then its velocity is becoming horizontal. So what is really happening is this inclined surface is giving an impulse to this particle, which is in this direction actually, but there is a component in the vertical direction, also a component in this direction. This vertical component is reducing the velocity of this particle. It had some velocity because it had fallen a height of h minus h. Now that velocity became 0, as now the velocity is completely in the horizontal direction. So there is definitely a vertical impulse. Now what that means is that the volume was falling. Now there is a vertical impulse, which means there is a hindrance. There is a hindrance in the path of the particle, and then it continues on its journey. So definitely, and this hindrance where it's stored is our variable, which is small h. So this hindrance will definitely increase the time. Now what do you think should be the ideal case where the time is minimum? Is when there is no hindrance. So let's say the body starts, okay, let's erase all this. Let's say that the inclined plane is here at the beginning. So when the body starts, it's at rest, it immediately hits this, and then it goes in the horizontal direction. So basically it is falling. It's basically falling as if the inclined plane was not there. What's the ratio in this case? H is h is equal to h, implies the ratio is 1:1. Now there is also a similar case where the inclined plane is at the bottom. Basically the hindrance occurs at the very last moment where the particle has already reached the bottom. So there cannot be any hindrance in the middle for it to be in the minimum time, which means either the ratio is 1:1 or the ratio is 0:1, which is this case. Now what they are asking is maximum time. So there is no reason, as you saw, the two identical cases for which it is happening in minimum time, there is no reason for the maximum time to be biased in any one direction, which means that h by h cannot be 2/3, cannot also be 1/3 or anything other than half. Because there is no bias, there are identical cases on both sides. There is a hindrance in the middle. You're trying to maximize, it will happen in the middle. So you can easily understand that this is half. These types of qualitative analysis of problems can land you in trouble sometimes, because the assumptions and conditions won't be very simple like this problem. They will be complicated, and then the most recommended approach is the analytical approach, which will never fail you. So unless you're extremely comfortable with the concepts, do not attempt this. But if you feel you're comfortable, you can definitely do this. This will reduce your time, because I didn't even do any problems. I just did a qualitative analysis and the answer came. So yeah. Next problem. A particle is thrown at time t equal to 0 with a velocity of 10 meters per second at an angle of 60 degrees with the horizontal, from a point on an inclined plane making an angle 30 degrees with the horizontal at the time when the velocity of the projectile becomes parallel to the incline. Okay, so the inclined plane problem. There are multiple ways to solve this problem, but I will show you one method because of this particular question is asking such a direct thing, which is why I will show you this method, which will reduce your times very much. This problem would take probably from 50 to 1 minute if your average speed, but from this method you will apply only one equation and this problem answer will come in 10 seconds. So let's understand that method, and it is basically a very simple concept of shifting your reference. And if you can understand that concept, you can apply it to other problems of inclined plane as well. So you should remember your basic projectile motion case, which is this, with an initial velocity u, a theta angle, it has a range, some height, maximum height. You should always remember the equations for this setup. The time it takes to reach here, the double the time it would take to reach here, the range, the formula for range. You should definitely remember this because they can ask you. It generally doesn't happen that they ask you such direct questions, but they can ask you for the base case in some situations. Here they just have modified the problem a little bit, but you will see that the problem is basically this with just a shift of values, which is the reference. Now here this is the ground. But here the body is traveling with 60 degree with the ground, but it's traveling with 30 degree to the inclined plane. So if we consider our inclined plane as the ground, what would it look like? Let's say u here is 10 meters per second. This is 30 degrees. Now what are the forces on this particle? Is g, right? So this component is g cos, sorry, this is g sine 30 degree, this is g cos 30 degree, and so this is the basic situation. Okay, so if we shifted our reference, right, so now this force in the vertical direction becomes g cos 30 degree, and there is a new force in the horizontal direction, d is g sine 30 degree. Now this case and this case are exactly the same, just with the difference of values, because the vertical acceleration or force, which is mg, you can say, is g in this case, but g cos 30 degree in this case. There is also a new acceleration in the horizontal direction, but basically the motional equations will be the same with just a shift of values. Now you have to understand what they're asking in the question, when the time and the velocity of the projectile becomes parallel to the incline. Now they're asking when the velocity becomes this, which is basically the moment. This is given by t equals u sine of the theta, this theta, by g, the acceleration in the vertical direction. Now you can apply the same logic here when, let's say, v dash, it would reach a position when it's parallel to this, which is this, which means t dash equals to u sine of the theta is 60 degree here, so theta minus alpha, which we can say is the angle of the incline, by g cos of alpha, which we can say is 10 sine 60 minus 30 by 10 cos 30, which is 1 tan 30, which is 1 by root 3 seconds. So option B is correct. So this basic yet nuanced technique of shifting a reference can help you to solve this problem in 10 seconds. Now I spent all this time just explaining the concept, but what you should be actually doing in the examination is just this part, just this, because this concept should be already well understood. All this that I did should already be well understood. It should be well defined in your mind so that you can directly go to this because you know what they're asking. So the problem can be solved much faster. Okay. A particle moves along the positive branch of the curve y equals x by 2, where x equal to t cubed by 3. X and y are measured in meters and t in seconds. Then, okay. Another problem where the question is basically in the options. So you have to give a quick glance over the options, what they're asking you. So basically velocity and acceleration is asked. A very brief glance. You don't have to read the exact values. You just have to know what they're asking so you can do what they're wanting you to do and not just aimlessly try to do whatever your mind is wanting you to do. So y equals t cube by 6 and x equals t cube by 3, which means Vy equals ddt of y equals t square by 2 and Vx equals ddt of x equals t square. Now what have they asked? The velocity of the particle at t equal to 1 second. Now v y1 equals to 1 by 2 and vx1 equals to 1. So option 1 is correct. Option A. Option B is not correct. Now let's talk about the acceleration. Ay is equal to Vy ddt of Vy. Now ddt is also represented by this symbol. When its time is the independent variable, when it's ddt of something, it's represented by this. It's called Vy dot. It is t, and Ax equals to 2t. Now what have they asked? Acceleration of the particle at t equals to 1 second. So ay1 equals to 1 and ax1 is to 2. So option C is also correct. The acceleration of the particle at t equal to 2 seconds is I plus 2 j. Okay, at 2 seconds ay2 is equal to 2, ax2 is equal to 4, but it's given 1, so this is not correct. So as you can see, it's just a basic, very basic question which just tries to see if you know what velocity and acceleration are basically, and the problem can be solved in, well, I did it by explaining. You should be able to do this very fast if the concepts are clear in your mind. Talking of concepts, this is one conceptual problem. A particle is going in a spiral path as shown in the figure with constant speed. Okay. So it basically asks about the characteristics of the particle, velocity and acceleration. So this is one type of problem they often ask to check whether you know a particular concept well, which in this case is a spiral. So for this you should know your basic uniform circular motion. What is a spiral basically? Now my drawing is not that well. Drawing is definitely not one of my strong suits, so please excuse me in that department. What you should know by looking at this picture is that this is well, all these circles are uniform for one, and the distance between these two, every one of these two is same, which means that the velocity in the perpendicular direction is constant. Now I'll explain what that means. So in your standard circular motion, let's say this is a V. This is not a sector. Okay, this is good. Now there are two accelerations. One is the tangential acceleration, another one is the centripetal acceleration. Now in uniform circular motion, this is 0, which is mod v is constant. There is a centripetal acceleration. Now let's study the uniform circular motion. Now as you can see, the direction of v is changing at every moment. So the velocity vector v is not constant. Same goes for the acceleration, which is this in this case and this in this case. So the acceleration vector is also not constant. However, the centripetal acceleration value, the magnitude, which is given by v squared by r. Now since this is a circle, r is constant and v, this is mod v. This is also constant. So this is constant, which means mod a is constant. So this is a standard case for a uniform circular motion. Now what is a spiral? See, a spiral, a normal spiral which they have given here in this case, is nothing but a body going in uniform circular motion. Let's say this is the xy plane. And this is the z-axis. Now in normal uniform circular motion, the velocity vector of the particle is always something in the xy plane in this case. Now if you also add a velocity vector in this direction, the z direction, then it becomes a spiral. Now I'm not going to draw one because that will make the drawing messy, but you should understand that when this Vz becomes non-zero, it traces a spiral. Now you should remember that this Vz and the velocity in the xy plane, Vxy if we name it, is independent of each other. This is not affecting this. This doesn't change this. This is in the perpendicular axis, perpendicular to the plane of the uniform circular motion. So this doesn't affect this. So all these characteristics that we discussed about the uniform circular motion are also true for a spiral. And since we know that Vz is not only not equal to 0, but it's also constant, the mod Vz is constant in our case because they've shown us that it is going in a spiral path with constant speed. So Vz is constant, and in uniform circular motion this Vxy is also constant, as we have shown here, this mod V. So basically we have just extrapolated this uniform circular motion in the z direction. There is no other difference in the characteristics of the uniform circular motion from this spiral motion. So all these are true still for the spiral motion. So the option A, the velocity of the particle is constant, is not true. The acceleration of the particle is constant is also not true. The magnitude of the acceleration is constant. Now see, since in the xy direction the acceleration, as we discussed, the magnitude is constant, and in the z direction it's constant speed, so there is no acceleration vector or component of the acceleration in the z direction, then magnitude of acceleration is definitely constant and it is not decreasing continuously. So as you can see, this problem just basically checks if you know what your spiral is. The basic spiral, what is the basic spiral? And nothing else. So it may look very confusing, but if you know what a spiral is, it is not that difficult. So you should always have your concepts very clear for solving physics questions. Let's go to the next problem. A train is moving with a constant speed of 5 meters per second, and there are two persons A and B standing at a separation of 10 meters inside the train. Another person C is standing on the ground. A moves towards B and back to its position in 10 seconds with constant speed. Then, so another problem where the options are the questions basically. This is a theme in multiple choice, correct? Okay, it's recordings. Okay, so we have to find the displacement by A in reference to C. Okay, let's do that. Now, basic concept of relative velocity is required here. So the displacement of A with reference to C is displacement of A with reference to the train plus the displacement of train with reference to C. Now C is a stationary body and T is moving at a speed of 5 meters per second. For now our concerned time is 10 seconds. So this is equal to 5 times 10 equals 50, which is 50. Now d of A with respect to the train, now they have said here A moves towards B and then back to its position in 10 seconds. So with respect to the train, A is back at its position, so the displacement is 0. So we got our displacement of A with respect to C. So answer A is correct. Now immediately you should cross out D, which says distance covered by A in favor of reference of C is 25 meters. And as you know, distance is always greater than or equal to displacement, so this option can never be correct. This is already 50 meters, it can never be 25 meters. So let's check the next option. Distance covered by A in frame of reference of C is 50 meters. Okay. Now for this, apply the same formula. This part we already calculated, since C is a stationary body and the train is moving in only one direction, distance will be equal to displacement, which means this is already 50. Now distance covered by A with respect to the train. Now A moves towards B. A and B are at a 10 meter distance and then back to its position in 10 seconds. So it covers. Now this is with respect to the train, right? So the train, so we consider the train is not moving with respect to the train. So it covers a total of 20 meters, a distance of 20 meters. So this is 70. So option B is also not correct, and ninth is option C correct, because we just saw that the distance covered by A is 20 meters and this says the displacement is 25, which is not possible. So as you can see, this is a basic problem with the concept of relative velocity. Now they will always, WBJEE will always ask basic problems based on basic concepts, which if not clear may seem difficult to you, but if they're clear and you break down the problem into doable parts, then the problem will be solved fairly quickly, and the speed, which is the real issue in WBJEE and which is really the test, will only come with practice. There is no secret, guys. There is no secret. Practice is the way to go. This is high time that you should have a skeleton on your mind about your own strengths and weaknesses. We are here to help you, but in the end, it is you who are giving the examination. It is you who should be clear about your own strengths and weaknesses, and you should prepare in that way. You should practice more. You should practice on your strengths, and you should always keep in mind that the problems, the concepts that you understand, the problems that you will be able to do are the problems that you definitely do on the day of the examination, because that is how you maximize your efficiency. So practice a lot, focus on your strengths, know your weaknesses to work on them, and just build confidence this way, and the exam will definitely be good.